In my previous video, I demonstrated how I could use a simple switching diode to act as an audio switch. If I forward biased the diode, I could allow an audio signal to come through, and if I reverse biased the diode, it would block or it would prevent the audio signal from coming through. Now, there were some problems with this, and somebody made the comment that you will get some clicking and some popping when you're switching the voltages back and forth. Well, in this next part, I want to show how I can alleviate that problem, but also extend the use of the diodes to mimic the function of the 3-pole double throw true bypass switch. Okay, let's take a look on the bench. To improve things slightly, I started playing around with applying 2 different voltages. So I had 1 voltage on one side and the negative or the opposite of the voltage on the opposing side. This was positive. I would make this one negative. So this diode would be well open and the audio signal could pass through just as normal. To deactivate the switch, I would reverse the voltages and I would make this guy negative, this guy positive. So now I have a back voltage to overcome. If this was, say, positive 5 volts and this was negative 5 volts, I have 10 volts of pressure pushing back this way, and the audio signal can't go through. Now, to mimic the function of the 3-pole double throw, you might think that I could just duplicate this circuit 3 times, 1 for each pole, and I certainly can do that. But with the diodes and playing around with the positive and negative rails here and changing them back and forth, I actually have another option. I can arrange a series of multiple diodes. I'll build up a little chart here. If my dark circle is a positive supply, my hollow circle is negative, let's take a look at what happens here. If this is positive and that's negative or ground, this diode is in the active state. So I can pass a signal from A to B or from B to A. So I can go from A to B or the opposite direction. For these center 2, if this is positive and that's negative or ground, what happens? This diode is reverse biased, so the path from B to C is blocked, so no signal gets through there. If we keep going down this path, he's positive, he's negative or ground. This diode is forward biased, so it's active, and I can pass a signal from C to D or from D to C. All right, so what happens when we reverse the polarity? So my filled circle is negative, hollow circle is positive. Let's take a look at this first pair. If that's positive and that's negative or ground, this is reverse biased and the path from A to B is blocked. Now the center section, if this is positive and that's negative or ground, this center diode is forward biased and so it is active. It's in the active state. So now my path from B to C is open. So I can pass a signal from B to C or from C to B. And last but not least, if this guy is positive, he's negative or ground, this diode is reverse biased, so the path from C to D is blocked. So that right there is the makings of a common bypass switch. So I could have in my true bypass state, which the signal comes in and it passes straight through to the output, I would want to use that center configuration. If I switch the voltages, this center path is blocked, and so now I can come in through this B input. This becomes my effects input, so the signal gets affected and comes on around. This will be my output, and this would be my effects output. That's my input. This is my output. This is my effects in, and this is my effects out. So just depending on how I place these rails, I can route the signal from this input directly to the output in a true bypass state, or if I switch the voltages around, the input gets routed to the effects in, and the effects out is routed through here to the output. Now, beyond the audio switching, I'm also going to want to have some kind of LED indication if the circuit is active or inactive. I set up something like this, where I have positive and negative, negative and positive rails here alternating back and forth. If this is positive and this is forward biased, my LED will illuminate. Now, I won't use 100K resistors here. I will probably use something much lower, up to as high as 10K. Now, I know I don't need to have 10K on either side, but for symmetrical purposes, I'll do that because it looks nice. I could also put in a second LED pointing this other direction. Like maybe this one will be green and this one will be red. Just something different to make these two states distinguishable from one another. Let's prototype these and see how it works. Okay, so the way I have that set up, it will come in, and depending on the position of these two switches, this will either be high and low or low and high. If it's in high and low, this is going to pass through to the output. If it's low and high, this is reverse biased, so the signal will travel through this diode to the effects send. It will come back through. This diode is forward biased, so the signal will go through and then to the output. That should work. This is not a great amplifier. I need to have something that runs a little bit cleaner. All of the distortion that you hear is coming from this really cheap battery-powered amplifier. Guitar in. The power to this. I don't have any indicator on this yet. Let me get that hooked up. I'm actually going to run two LEDs. So one of these will come on when it's active. The opposite one will come on when it's deactivated. All right, so there we go. Okay. And if I switch both of these, the LED should switch. And it does. All righty, here we are in the off state. You can probably hear the guitar a little bit over the microphone. If I turn these on, LED switches. So it works as a true bypass. Whoa. It works as a true bypass, and it also has the LED indicators. And that's all well and good. Let's actually hook up something. I'll have to use some alligator clips here, but let's hook up something to the effects send and receive and demonstrate that this is actually rerouting the signal. Right now there's nothing there. So I go from having signal to being in the off state again. Okay, I have a tremolo circuit that I made some time ago. I'm gonna get this thing hooked up. the ironic thing is that I've been working with an on-off switch, and in the on position, I actually am going straight through. Now the off position is actually the effects bypass path. So that's why this has kind of confused me at first here. Wow. Well, it worked, but that is probably the noisiest switch I have ever heard. All right, I have rejiggered this. I now have a bipolar power supply on here. So instead of having these toggles go back and forth from positive 9 volts to ground, now they're toggling between plus 9 volts and minus 9 volts. So I have 18 volts difference between the power rails. And to make matters more easy for testing, I have the effects send and the effects received. I just have this single alligator clip running around there. If I disconnect this, it should be quiet. Of course, I'm in the on state. If I turn it off, I have no signal coming through until I connect this. I'm going to hook up my effect here again. It may still be noisy, but I'm going to see if I can improve things using the differential power supply.
A few moments later.
All right, I have my effect hooked up again off camera here. You can see I've got some alligator clips coming in there. So that cleans it up a bit. So what have I learned from this experiment? I probably wouldn't use this in an effect because it does seem to be extremely noisy. Now, I could chalk that up to just being on a breadboard, and I know breadboards are going to be noisy, they're going to be glitchy. On the other hand, what I did learn is that using the bipolar power supply really does clean things up a lot. It also seems to reduce the clicking and the popping from switching the voltage back and forth. And that's because the diodes, where they sit in the power rails, they're near the center. So they're near ground while the resistors are pulling high or they're pulling low to the positive 9 or the negative 9 volts. Okay, so there's something to be learned there. This could be drastically improved. That's another thing. So while I say right now, I probably wouldn't use it for an effect, not in the state that it's in. But there are still some useful behaviors for diodes that don't involve just the clipping or the full wave rectification like we would use in a power supply, or the clipping or the limiting that we would use in a distortion pedal like a fuzz or like a rat distortion or something like that. There's something else that a diode will do, and I'm going to get to that in the next project. So if you're interested in seeing that, I do encourage you to subscribe to the channel so you can check in on that as well. I promise that one's not going to be as much of a stinker as this thing was. All right, catch you then.